Hey, good afternoon. Thank you for joining the session. So my name is Ram Madali. I'm a specialist solutions architect focusing on containers. So today the topic we're going to discuss is on EKS Anywhere. Recently, meaning last year, we GA'd the product. So the focus of it is essentially to kind of help you understand some of the things around EKS, how you can provision a cluster, what are some of the things that you look at when you're provisioning with some of the providers that we have, and things like that. And also, if you have any questions, feel free to either ask on while the session is going on. But it can be parked, then we can do it in the last 10 minutes. So it's up to you. So with that, so let's just get it going. All right, so let's first look at why part of it, right? So what are some of the challenges that EKS Anywhere is trying to solve? The first thing is around the important thing that is essentially not all customers can be in the cloud, right? Obviously, there are some regulatory concerns and where the data has to be on-prem and things like that. So essentially, for customers who wants to run the Kubernetes cluster close to the data, that's one problem that we're trying to solve. And then the second thing is around also using the existing investment. It could be the infrastructure investments they already have, or they're probably at least for the next few years, they want to still continue to use those investments. And then the governance aspect of it, to make sure that they're running whatever the Kubernetes clusters are running along with the applications and all that is secure enough, and to be able to audit and do all sorts of other things that you usually be doing in a regulatory sort of environment, right? And then also operating the Kubernetes across on-prem as well as a cloud. So there are some customers who either start in cloud and as well as some customers who either start in on-prem. But the experience around whether you start on-prem or whether you start on the EKS, it still has to be kind of similar. So our goal is to give you that consistent experience, whether you're doing on-prem or on the cloud. So what is EKS Anywhere? So first of all, it's the same bits that we're using for the EKS, right? That provisions or that powers the EKS itself on the cloud. So one is the EKS distro, which is the actual bits that contains the packages, images, etc., that powers the EKS. And then the other part of it, the EKS Anywhere consists is the tooling. So the distro itself, if you want to just download the distro from our repos, you can certainly do it and run it. But what you would be not getting it is the toolings that are required, like the EKS Cuttle or other toolings and other components that we include as a part of the EKS Anywhere, right? No, the toolings like we include Cilium, we include the actual EKS Cuttle, we GitOps tooling, and many other which we can go through the following slides. But the important part is, whether you do it on here, meaning on-prem or on the cloud, you're still using kubectl as the CLI tool. And then for some part of it where you're managing or for the actual operations on the VMware or any other clusters, and then you'd be doing either through kubectl or through the typical the APIs that you were already doing before. So right now, the two providers that we support with EKS Anywhere is one is the VMware. We require at least a 7.0 as a version. And then the second one is the Docker. And the third provider which we're working is on the bare metal, which we should be seeing the actual release sometime soon. Right now, it's in the private beta environment. So let's look at the overall EKS portfolio, right? So that you kind of understand, where, which one can run where and things like that. So the first one is the EKS distro, which is what I was referring in the last slide, where this is the code and the image and the actual bits that powers the EKS itself. That you can take it; it's free of charge. You can run it on your, in the on-prem or anywhere. But you would be managing that entirely by yourself. You are responsible for, the control plane, data plane, etc. Whereas the EKS Anywhere, you can run it on your own hardware. In this case, like I said, the two providers that we support today, and we're looking to add more providers as we go. You can run it on-prem, as well as in terms of the responsibility, this is supported by AWS, as in whatever toolings and other aspects that we include as a package. in the EKS Anywhere, it's all supported by AWS. But the responsibility of managing the control plane in terms of patching and all the other stuff is managed by is the customer's responsibility in that case, right? And then the Outpost is if you are the difference between the Outpost and Anywhere is Outpost, the control plane itself is running in the cloud, whereas in the Anywhere all the components are running in the on-prem itself. So with respect to EKS, it's a fully managed service, which means all the responsibility of the control plane, the data plane, the control plane is responsibility of AWS as well as you can run that in the cloud itself, right? So I was referring to the components in the previous slide. So what are the components we're talking about? So the two operating systems that are supported today is Ubuntu, which is the version 20.04, as well as Bottle Rocket, which is a purpose-built container operating system that we built and released last year. So those two operating systems are right now supported, and we are looking to add more down the line as well. Is it bundled today? Yes, those two are bundled, which means you get the actual AMIs for when you're spinning up, or the OVA templates when you're spinning up those EKS Anywhere clusters. And then the components like CDM is for the network, the actual network interfaces, right? As in, it's an overlay network where when you enable it, you're getting an overlay where the entire network, as in the virtual VLANs and things like that. With respect to all that is being taken care of by the CNI plugin, in this case Cilium, and then it's bundled as well. And in terms of the GitOps, we package Flux v2 as a component where the source code itself. I'll be showing you a demo where even the creating the clusters and all that, the source code will be in the Git. So the controller, which is kind of looking at the actual versions or the source code in the Git, is reconciling that state back in the cluster, whether it is a data plane or whether it's an app that you want to scale or things like that, right? And the storage aspect, we don't really include any, as in the actual storage driver itself, but we just include the CSI driver, as in you feel free to use any of the driver. In this case, if it is a VMware the CSI driver, can certainly use it. And then from the lifecycle management of cluster, as well as the data plane, you would be using, we include a CLI, which is a EKS Cuttle, which along a plugin called the Anywhere plugin, which I'll show you in a bit. Essentially, you would be using that to upgrade or do any lifecycle management aspect of the cluster, as well as the scaling of your applications using the Flux in a typical GitOps way, right? And then the last one, which is the optional component, is the console, right? So one of the use cases we're trying to solve is, since you're spinning up multiple clusters, either in on-prem or in the cloud, now how do you see all those clusters in one place in a single pane, right? So that's where you can enable this optional connector component, where you can, all that basically it's doing is essentially sending the actual details of the cluster back to the AWS console, which in this case is the EKS console. So if you go to the EKS console, then you would be seeing all the clusters that are running either in your on-prem, as well as actually in that case, it doesn't even have to be a EKS Anywhere. You can also be a plain Kubernetes cluster, where you can see it from a list of clusters that are running today on the console itself, including the EKS managed service clusters. All right, so let's look at the flow, as in how is the flow, as in when you're creating a cluster, and also the architectural components, et cetera, right? So you can spin off right today with on VMware vSphere. That's out of the two. The first one is the Docker, which is only supported on the local development. The second one is the vSphere, which you're spinning up in the customer infrastructure, right? So using the CLI, EKS Cuttle CLI, you are bootstrapping a cluster, which we call as a management cluster, using the CAPI interfaces. Essentially, that bootstrap cluster is going to generate the actual workload cluster, which you would be configuring to run your workloads on it. And then, as you can see, it's basically you can generate a pre-generate a canned configuration file, and from there we would be kind of giving what is your pod IP addresses, CIDR ranges, and other minimal details that you require. And then from there, by default, the CAN one gets you 3 control plane and 3 XCD nodes, as well as two worker nodes. Again, you can certainly edit it before you're creating the cluster itself. And then we were talking about the connector component. In this case, it's connecting back to the service control plane. The connector itself sending the data. Again, that's an optional one. And the connections that you need from the on-prem to the cloud are essentially 2. One is the ECR, and the other one is the S3. And in terms of the ECR, this is for downloading the distro images. Since remember, we're talking about the EKS Anywhere depends on the EKS distro as well. So it downloads that EKS distro. Certainly, you can cache it. Down the line, we are looking at a local registry kind of an option, where in that case, you don't even have to have a ECR as a repo connection. And then the last one is the S3. You need it because of the OVA templates. So we ship OVA templates by the providers. If you have a OVA template, you can certainly customize it. We will use those customized OVA templates. If not, you can. We will be downloading the actual OVA templates that we provide from the S3, and then in that case, that's why you need a S3 connection. Right. So those are some of the components in the overall architecture and the connection that you require from the on-prem to the cloud. Now, in terms of upgrading, what are some of the things? What is the checklist of in terms of how do we upgrade the data center, the data plane, the control plane, and the vCenter config? So from the control plane aspect, you would be doing the upgrades in terms of whether it's a master node, XCD. All that will be done through the CLI, which is EKS Cuttle in the case. And then for the data plane, you can do that using the EKS Cuttle as well as through the Flux, the GitOps mechanism. And the vCenter config, which is what is based on the CapV, right? Essentially, it's a way to where those are defined as a custom objects within the Kubernetes. So you can certainly change the configurations from the Kubernetes itself, either from using the EKS Cuttle in terms of either spinning off, changing the config for vCenter, or even for the data plane, changing the stuff on the data plane like node count and things like that. So let's get into the demo. So just show you some of the aspects we were talking about. All right, so the first one is we were talking about the Bootstrap cluster, right? So the way we do it is essentially you would be doing using the EKS Cuttle, you'll be creating a cluster, and from there, there is a Bootstrap cluster, which is generated based on the config, just the one config file that you will have. From there, using it will be spinning up the actual target cluster. In this case, you call it as a workload cluster, right? Which is the control plane, the worker nodes, and then the management plane itself. And then once this is done, this Bootstrap cluster will be gone. And then, but if there is an issue in generating the actual target cluster itself, the Bootstrap cluster will still exist, so that you can see the errors or anything that you need to debug for in terms of why the cluster itself is failing, right? So that's one of the way that's actually the flow in terms of the creating the cluster. So right now, I have vCenter client, and then we created all the data center config, et cetera. And I would show you some of the stuff as in. So using, you can, like I said, I was talking about how do you generate sorry. Yeah, so I was talking about how do you generate the CAN config, right? Essentially, you can certainly do the using the command. You can certainly generate a CAN configuration. Once you do it, you will see a config file or a YAML file here, which is essentially. Let me walk you through some of the aspects. All right, so it starts with actually you're defining so how many how many nodes you need in a control plane. What do you need in terms of the nodes? How many nodes you need how XCD nodes you need, and then if you're enabling the GitOps provider, then you are talking about how do you enable a GitOps provider here, meaning you're configuring it, and then any other the machine config itself, right? So as you can see here, the first one is we are talking about the XCD configuration is which we are saying the count is 3, and then we are referring to that machine config. And then we are also looking at the Flux config, referring to the Flux provider, which I'll walk you through a little bit. And then the worker nodes, which is where your data or the apps are running. So in this case, we said we're going to run 2 worker nodes, and then the other details, as in like what is the control plane aspect of it, which is something is missing here. It's much more easier to run. Yeah, so you'll be configuring the CIDR blocks like this, as in like what is your CIDR block, for the pods as well as for your services, which is the virtual services. That's one layer above your pods. The control plane in this case, the 3 as a node, the nodes, and then the actual references that it's making is essentially under the actual machine config, right? This is where you would be talking about how your machine is going to spin up. In this case, like I was talking about the OVA templates. In this case, I gave one of the OVA templates here, and then talking about the things like number of CPUs and the disk size. Again, these all are customizable if you want to kind of configure by based on your use case, and then the node group itself, right? This is where the actual worker, your apps are running. The config, again, this is going through the OVA template. And then the GitOps itself, since we're referring, remember I showed you the reference where we're referring the GitOps provider. In this case, this is my provider, and I gave the GitOps as a GitHub my user, and then the repo, and then the namespace that all the Flux system or the components will leave in the EKS Anywhere cluster. So again, so you would get a CAN file, and from there you would be starting to probably just to configure the essential aspects around CIDR and things like that. So once you do it, you would be creating the cluster using the create cluster command, which I'm not going to run, but essentially this is once you run the create cluster, what happens is it's going to validate your configuration file, things like whether machine itself, the actual OVA template itself exists, any other certificates and other aspects that it does, like around 20-25 checks, and then the actual GitHub, the connections for that you are mentioning around the Git, right? Once that is done, then the cluster will be spun up. So again, that's just one command that it will take around 15 minutes to kind of run to get the command. So I pre-created the cluster, but as you can see, based on the configuration I walked you through, you basically have the three masters in this case, as you can see on top, and then the 2 worker nodes. You can run the XCD as a co-located, as in on the same master, as well as you can also run XCD actional to the master. Both the options are supported. In this case, I'm running the version 1.221 as well. And then that's the 1.22 is also the, I believe 1.22 is the latest version. And what are some of the things that, so I want to show is around the, now in terms of the integrations, right? So if you want to integrate with other aspects like, other aspects like load balancers or any other stuff that you require. So we do support the integrations. Like for example, you want to expose your your cluster to obviously either to internal or to internet. Right now the MC ingress is supported, as well as the typical Kubernetes way of service load balancer, either kubevip or metal LB, right? The both the ways are, the integration exists today. And then if you want to spin up the local image registry where you don't want to get to the ECR, the images itself, you can certainly do it from the hardware itself. And the monitoring wise, today you can use CloudWatch agent on the actual cluster itself and send the data back to the CloudWatch, as well as the Prometheus, including the AMP, the managed Prometheus and the managed Grafana in terms of the monitoring and the metrics, right? And then certainly you can use the FluentBit to send the logs back to something like Splunk if that's what you prefer in terms of the integration, right? And then so on and so forth. You see the cost management wise and other aspects that are integrated. But one thing to note is these are not the directly supported by AWS. That means something that you would be supporting through the vendors or however you're doing it today, right? So. And then so once you get the cluster, some of the things, if you want to get an app running on the cluster itself, which right, so these are the namespaces that exist today. Also, if you want to look at some of the custom objects, essentially for the actual EKS Anywhere to work, there are a lot of custom objects as in not the custom AWS objects. These are specifically the CRDs that comes to kind of manage the cluster itself. Things like the VMware config, all that exists as a custom object, right? And if you see the Flux system namespace itself has the Flux component associated to it, and then the connector, which we talked about around connecting back to the console, that exists in that EKS connector namespace. And then so on and so forth around the other aspects like kube public, kube system, the cert manager, and all the other aspects. Now, if you want, we can quickly look at an app, as in like once you create a cluster, one of the things that you would see is since I enable the GitOps, it automatically creates this folder or it checks in that stuff back into my Git. What does it have? It has two folders. So one is the actual cluster itself. Another one is the actual Flux components that it enables, right? So let's look at the cluster itself. In the cluster, this is the config that we walked through just now. That the actual the tool EKS Kettle used to create the cluster. And then the second one is around the Flux itself, right? The things like the K customization and the components, etc. Now, if you can certainly do a change either from here or from the actual cluster itself, from here, and then check it in back, and then the actual controller will look for the changes in the Git, and then spins off a particular. And if you want to, let's say, let's try to scale the. Before we scale it, let's see how many nodes we're running, right? So right now we're running 2 worker nodes, right? And then the control plane. Now this is my cluster file that I was talking about, which is EKS. Now, as you can see, this is my worker node configuration. Let me go to the actual my workers to increase that from 2 to 3. So that's my control plane. This is my XCD. This is my Flux, and this is where is my. Now let's make it a 3, right? Now let's just commit. Yes. All right, so it pushed that change back to the Git. Let's just make sure we see it here. Make sure I refresh it. Where is my config? Yes, the worker node config went to 3. So I checked in. Now let's kind of watch the nodes, right? kubectl at nodes. It should be eventually, spinning up the third one. While it's doing it, anybody have any questions? Yeah, as of today, that's the only one, and we are working on the bare metal support, which you should be seeing it in probably a month or so, I believe. Somewhere Q2, I believe, end of Q2. No, this is an admin machine basically. It's just if you look at my vCenter, right, it's one of the admin machine under one of the VM machine on the vCenter basically. The actual admin, yes. Then and from there, it spins up the actual cluster into the rest of the other nodes, and then it gets deleted after that. Yes, they are. We are working on, again, there are some right now that exist. Like, for example, we are talking about CloudWatch. We were talking about CloudWatch. That's one integration. AMP is another integration, like the Prometheus, main is Prometheus. And then the other one is the Grafana that exists. And then the other integration that we are working right now is through the actual cert managers is another one, and so on and so forth. There are many integrations that are coming up, but right now it's some of them are prioritized based on the customer request. So if you have any specific use case, certainly we can help you do it. Yeah, so what I wanted to show you is that as again, so once you change the nodes itself from 2 to 3, you would be seeing the actual cluster coming up with the 3, with the nodes. That's one. And then for the application itself, you go and change the actual application objects. Like for example, you deploy through the kubectl some of your application, and then for example, if you want to scale your deployment from 2 to 3, either you can do it in manual, the semi mode, which is what is through the GitOps. You're essentially configuring it at the Git level to change it from 2 to 3, essentially. So we talked about the integrations is one thing that we talked about. The scaling is another one we talked about, as in like the actual cluster scaling, which is either through the GitOps way, which is where you're configuring it through the either through Git, whatever you're changing, and then the Flux controller itself reconciling the state back. Or the second way is the third way is actually the cluster autoscaler, which is what we're working, the dynamic scaling part of it, right? That is the part that we're working on, which you should be seeing sometime this year. But the manual mode and the semi-automatic mode, which is through the GitOps, works as of today. And then in terms of the patching, again, let's say if you want to change the VMware config, or if you want to change interact with the APIs itself, you can certainly interact it through the EKS Scuttle, through the plugin. So EKS Scuttle, so the way you do is like I showed you in the command, essentially EKS Scuttle anywhere, and then you would be talking about the custom objects that like machine config is an object. Like if you want to change the machine config or anything, you would be just interacting through the EKS Scuttle itself. Yes. So the Flux is a GitOps. So essentially, it's implemented as a controller that's running as a pod within your Kubernetes. It's watching your Git repo, trying to see, as in if you do any changes, anything else, then it brings back that state to the cluster through the manifest files, which are manifest files that you have. So in this case, since I enable the provider when I'm creating the cluster, all my config files go to the GitHub, including my cluster config files, my machine which are the CRDs that all go to the Git, and then if you change anything, just like I was showing from 2 to 3, essentially that you would see the state console back to the 3 as a worker nodes in the data center. This is running as a controller. It's not a daemon set. The S3 has the OVA templates. Remember that I showed you the template, walked you through some of the templates where it's talking about how so obviously, since we are packaging some of the components, there'll be an opinionated version of it, as in like how the VM itself should look. So that's a template that you can certainly, if you don't have the template, it's going to go and pull it from the S3. If you have it, it's going to use the local copy. So having it obviously makes the creation of cluster much more faster.
Before you get to the EKS provisioning, say on whether it's bare metal or VMware, do you normally have like a Terraform provider with VMware to spin up the actual virtual machines before you get started?
Yeah, right. Yeah, you can certainly do it even with EKS Anywhere too. There's a EKS
So you don't need the Terraform then, so I can use your EKS Anywhere to do the VM provisioning straight.
Correct. You don't need the Terraform you're not using it. But the actual, like I said, one of the slides we talked about in the previous one, right? So we're talking about how the upgrade. So what you want to see is how you whether you want to do the infrastructure as a code, including the GitOps, right? So in this case, if you look at the upgrade and scaling the mechanisms, the CLI itself supports all the 3 aspects, right? And then the Flux is supporting the data plane aspect of it, which is changing the node count that we are walking through, including changing the CP count, etc. And if you want to do with Terraform, certainly you can do it as well. Yeah.
And we use Argo or Flux.
So we include Flux. If you want to replace with Argo, certainly you can. But the advantage is if there is any issues, obviously we support it. But with Argo, we don't support it. Yeah. Yeah, so those are again, as you can see probably the rest of the year, we would be including many of other components as well. But right now, this is what is included as a part of the components. Right? Any other questions? Yeah, it's still through the IAM. So you can certainly get back to the OIDC provider. And then in this case, for the EKS connector, right? So it requires IAM role. So you'd be configuring IAM role to talk to the actual console back. Again, for your own integrating with your LDAP or anything else, you'd be using OIDC. If it is the actual calling other AWS services, then you'd be doing the IAM roles. Yeah. Yeah, the bare metal support is something that's coming up. That should be shortly. If anybody are interested in the part of the private beta, and certainly reach out to us to help you be part of the private beta. Yeah, so the documentation is on the EKS Anywhere, anywhere.eks. So you can certainly, there are a lot of documentation there. One of the things which we kind of talk a little bit is on the load balancers, right? The integrations with the load balancers and the other aspects, right? So certainly you can integrate with the 2 load balancers I showed, metal LBs and one for if you want to expose the service itself back to internet. Again, these are running as the pods within the Kubernetes itself, and then the other aspects like any other integration that we talked about, right? As in the monitoring, logging monitoring, or the metrics, Prometheus metrics integration, etc. So forth. That's right. So just imagine if you're running on the AWS, that means the storage, things like S3, sorry, EBS or EFS, these are the drivers that we ship. But when you're running it on VMware, obviously the storage is much more specific to the VMware. So they have the CSI driver. So you'd be using the drivers from either VMware specific storage or things like NFS or anything like that. That using.
Are you aware of any storage providers like, say, SolidFire that have created drivers for EKS Anywhere?
No, I'm not aware of any certified driver. Like I said, any CSI implementation driver you would be able to use with EKS Anywhere. So you can pretty much use all the CSI drivers. Oh, is it okay? I was too busy. I should have just checked it. I did another session just before I was coming here. I didn't realize it was running. Should have plugged it. But anyway, this is a whiteboard session, so I think we can certainly talk through the whiteboard as well. No, my laptop itself died as a charger. Yeah. So who is trying EKS Anywhere? Someone is trying in this room, as in trying to either use EKS Anywhere or at least EKS. Anybody is using EKS or ECS?
Yeah, we got some EKS.
Yeah.
We got folks that have been doing EM and EKS and they want to get like a unified
So you're trying the EKS Anywhere because
they've been doing EKS for a minute and they're thinking about Anywhere. They like to just have a single way of managing.
Right, sure.
They're also downsizing a lot of their racks, so they like to start using it more efficiently.
Okay. Okay. That's cool. Yes. There is a private beta that's going on. Usually it's by invite, or if you have the account team, reach out to your account team if you are having an account team, or let me know. I can just connect you with the account team. So they will sign you up for the beta, private beta. This is for the bare metal preview. So the difference between the two differences is within the ECS Anywhere versus EKS Anywhere versus the other one, which is the Outpost, right? There are a lot of customers either, earlier before EKS Anywhere, obviously a lot of customers were using Outposts, right? Certainly they can still use. It's not that we are trying to replace Outposts or anything else. Both are complements and they're specific for both different use cases. EKS runs on Outposts. So what that means is the control plane is connected through the cloud, right? It's not running in the actual the appliance itself. But in the case of EKS Anywhere, both the control plane and the worker nodes are running on the same on-premise data center. And then if you're talking about the integrations with database and other AWS services, Outpost does all that itself by versus EKS Anywhere. You're integrating through through either controllers, which act the Kubernetes controllers way of connecting back to the database, or any other service through the IAM authentication, etc., and so on and so forth. Sure.
The demo you were going to do, is that available on the website?
Yeah, I can. So just my GitHub URL is rmadali, which is at the end. So if you can, yeah, it's there already in my Git repo. But I believe, so that by default, it's when you're enabling the GitOps, it checks as a private repo. You may not see it, but I'll enable it as a public. Yeah, yeah, no problem.